In our last video, we looked at some basics of graphing cube root and square root graphs. So if you're looking for some basics, maybe go back and watch that one. If you're looking for the more complicated examples that I talked about at the beginning of the previous video, well, here they are in this separate video. So again, we're going to do the same three things. We're going to make a sketch of the graph by plotting one point. We're going to make a detailed comparison to the parent function, and then we'll finish by stating the domain and range. So there's the three parts I want to answer. Now, in our first example, I'm going to start with actually my second step here, or my second direction, make a comparison. So I'm going to draw an arrow pointing to each of those numbers, and I'm going to say specifically what those numbers do. Now also, watch how I do this completely without even touching my graphing calculator. If you want to see some things about how to graph these in the calculator, I'm going to put that in my next video, although I'd recommend you don't even use one for these. I'm going to go ahead and group this x minus 3 in parentheses, noting that that x is underneath the radical. That's important too if you are using your graphing calculator to use those parentheses. So those plus and minus numbers are going to be our shifts, whether the graph has been shifted or moved left, right, up, or down. A number underneath the radical, grouped with the x like that, is going to be our horizontal shift, but remember, it always does the opposite of what it looks like it says it's going to do. So if I see a negative 3 underneath the square root, I know that that's not moving it left, but that's actually going to be moving the graph right 3 spaces in the positive direction. Any number outside the radical, being out at the end, is going to move our graph up or down, and it does what it says it's going to do. So I'm going to move this graph up 2. So there's the two descriptions for what's happening. I can use those now to make a sketch of what this graph looks like. So I'm going to start by plotting that one point I talked about. Now normally it's at 0, 0, however this time it's not. It's actually been moved 3 to the right and up 2. So that's where my graph is going to be begin from. It's probably important to know whether I'm dealing with a square root or a cube root graph, because that has a very different shape. A square root graph is that hook shape, half of a sideways parabola. So I'm just going to kind of make a rough guess of the graph and say it looks something like that. If you want to be more accurate, you can plot some points and take a look at how I do that in the next video. Alright, and then let's finish this up by stating the domain and range. Domain is what we're allowed to plug in for x, or if you think visually, it's how far right or left the graph goes. And I can see that this time the graph is starting from 3 and then moving to the right. So my domain is actually going to be x has to be greater than or equal to 3. Well, have you seen any other 3's in this problem? Hopefully you're saying yes to the video, although that's weird if you're talking to a video. I have a 3 there, a 3 there, and a 3 there. So it turns out that not only does that tell us what our horizontal shift is, it also tells us what our domain is. Our range, if we want to think visually, is how high or how low the graph goes, so the y direction. So this time, the lowest point the graph gets to is 2, and then it increases from there. So my range has to be y is greater than or equal to 2. Once again, I would say, have you seen a 2 anywhere in the problem? And hopefully you're saying, yeah, it was there, it was there. So that k value, the number we're adding, tells us our range as well. Okay, let's go ahead and take a look at this cube root graph, and then we'll wrap this up. So again, I would probably go ahead and put parentheses around that, since that x plus 4 is underneath the radical. Since the plus 4 is underneath the radical, that'll be my left or right shift, and it does the opposite of what it says it will do. So rather than moving positive 4 to the right, I'm actually going to be moving left 4. And then there's no vertical shift, there's no numbers outside. So that starting point's normally at 0, 0, but now it's been shifted. So backwards 4, 1, 2, 3, 4. There's going to be that new starting point. I'm noticing that I have a cube root graph, so those were the graphs that had that sort of S shape to them. And I just want to make sure that that crossover kind of happens where I put that one point. So I'm going to kind of start low, swing up and cross through there, and then kind of flatten back out and include arrows on both ends. So there's sort of what a very rough sketch of this cube root graph should look like. Now to finish this one, I need domain and range. If you recall from class or from the last video, domain and range for a cube root graph is really easy. We can take the cube root of anything we want to, whether it's positive or negative. There's no restrictions. The graph doesn't end. It goes forever in both directions, up and down and left and right. So I would just say the domain and range is all reals always for a cube root graph, no matter what you do to it.